So here I'll qualitatively graph this function. So at x equal to 1, it's 20. So that points 1, 20, 3, 4. At x equal to 4, it's minus 4. So somewhere here. So we know the function passes through these 2 points that's given. So questions, which of the following must be true under all circumstances? They're saying, is the derivative negative for all x between 1 and 4? So between 1 and 4. Well, it could be true, meaning if it's, for example, something like that, then the slope is negative. But it doesn't have to. It could be, the function could be like that, in which case, in this interval, the derivative or the slope of the tangent line is positive. So that would negate this. So it's possible, but because the question is must be true, one is ruled out, because must be means under all circumstances. But it's possible that the f prime x is actually positive. So if we look at 2, there exists a number between 1 and 4 such that f of c is 0. And because we're given the n values, we know that because the function is differentiable, it has to cut across the x-axis. So there has to be a point, which is really the x-intercept, for which f of c is 0. So and it's going to be between 1 and 4. So 2 must be true. And then the third one is that there exists a point between, again, 1 and 4, such that f prime c is minus 8. Now, we're going to use the mean value theorem for that. So if we look at the two endpoints, so the mean value theorem is that there exists a point C where the slope of the tangent line is equal to the slope connecting the two endpoints. So here, this is one endpoint, that's the other. So if we compute that for this case, 20, which is the value of the function here, minus 4 divided by 1 minus 4. So this would be 24 over minus 3 is minus 8, which is exactly that. That means there will always be a point C that will satisfy this condition. And graphically, the way you can think about the mean value theorem is that if you're given a function like that, and these are the two endpoints, so that's dashed line, the slope would correspond to that, and there will always be a tangent line which will be parallel to that. That's the graphical meaning of that, is that this tangent line will be parallel to that chord formed by these two endpoints. So that's what the choice 3 was. So that must always be true. So the answer is 2 and 3 only, which is choice D.